Okay, so let's start discussing the chapter number 8.1, that is database concepts, and a very short introduction for databases. That first of all, what is a database? Right here, a database is to be known as a structured collection of items of data that can be accessed by different applications or programs. That means that when I'm referring to a database, the term itself states that I have a collection of data, I have a cluster of data, I have a bunch of data, and it is located at one place. Data base. That means that all of this data is actually located at one place, and it can be accessed by different applications for their further use. This is what it really means regarding a database. That it is a structured collection of items of data that can be accessed by different applications. The next part is the relational database. Relational database are those that are linked by each other. For example, I have name, first name, second name, contact number, address. And specifically, I'm referring to a student, for example, Ali. So whatever is going to be the address, first name, second name, last name, and contact number of Ali, that is not going to be of another student. That means that this is an example of a relational database that all of them are in a relation with each other. What is a table in a database? A table is a group of similar data with rows and columns, right? A table is a group of similar data in with each other. You can take off it as an example like if I have a table for student's name, in that table, I'm going to have different rows. What are records in a database? Records are basically the rows in a table. Records are rows in a database. Similarly, what are fields? A field is a column in a database. You need to memorize this, that when I'm specifically referring to records, that means I am referring to rows. Whereas if I discuss regarding fields, that means that I am referring to columns. Now this one tuple is to be known as anything that can have a data stored. Oh, one instance of an entity, which is different, represented by a row and a table. That instance means an example of an entity. What is an entity? Entity is a one object that I can store any data there. For example, it could maybe person, place, event, or thing. What are different attributes? Attributes can be categorized as the individual data items stored for an entity. For example, it could be a person, it could include a name, it could include address or date of birth. What are candidate keys? Candidate keys as an attribute or smallest set of attribute in a table. I'm going to give you an example of the candidate key as well. Primary key. This is a unique identifier for your table. Secondary key and a candidate key that is alternative to the primary key. That means that it is yet not the primary key, but it is an alternative to that. A foreign key is a set of attributes in one table that refers to the primary key. I'm going to give you an example of all of these keys so that it's easier to you. What are relationships? Relationships are situation in which your one table is connected to another table through any foreign key or primary key, secondary key. What is referential integrity? That means that the property of a database does not contain any value of a foreign key that does not match to your corresponding primary key. Now, if I move further, the very first content from your syllabus is a file-based approach. And you know it already that what is a file? A file is a collection of data items. It can be structured as a collection of records. Like I have all of records at one place where each of your record is made up of many fields. Like for example, uh, file-based approach. And in that file-based approach, I can say that I have I can say that I have a collection of records and all of these records are going to refer to you as fields, and all of these fields might have different data. I can even have individual elements which can be known as your data item. So the point is that whenever a program is used for data processing, that means processing the data in terms of your database, the organization of any record used depends on how the program is written or how your processing can be retrieved. When it comes to records, this one, they can be either fixed or variable in length, and each record may also contain information about its structure. For example, the number of fields or the number of records it had. So if these records are to be processed by another application, that is the basic definition of your database. The database refers to the collection of data that is processed by different applications. So I need to look into account that what is their record structure. So if the structure of your database is changed by one program, the other program must be rewritten as well. Why is that? Because when it comes to a file-based approach, as you can see right here, I am given an example of two files. Like for example, in example one, number one, I have a record structure. Earlier, I was discussing with you that in a file-based approach, a record structure is highly important because I'm going to have a first name, I'm going to have a second name, I'm going to have an address, phone number, of staff number. But the point is that all of these structures are directly linked with your payroll program, and your payroll program is creating your record with the help of a record description, validation rule, and processing code that is taking all of the values from here. I just mean to say that these three processes are taking one, two, three, four, five record structures from here. And similarly, four record structures are being used for three tasks here as well. What you need to look closely here is that all of the record structures of payroll program cannot be linked to the record structure of your CS programs because they are separately written and they are separately accessed. Like this record structure cannot share links or files here, and this cannot share links or file here. They are completely different structures. But what is the problem in this file-based approach in this is that you can have the problem of your data that can be stored twice. Like for example, you have the problem of your data redundancy. Your data is duplicated. Why it is limited? Because your storage space is wasted when data items are duplicated and there is no application to maintain the data. Data can be altered by one application. It can be used by one application and altered or edited by it, but it cannot be by another. So since it becomes inconsistent, inquiries available. What are basically inquiries? These can be referred to as queries. Now, whenever I'm going to apply a query on my database that, for example, filter me out all of this structure. So it can depend on the structure of your data and the software used so that the data is not independent of itself. So these are some of the problems in a file-based approach, that your data could be duplicated, your data could be altered, and it do not maintain consistency and accuracy with your database. So how can you solve this? You can solve this by a database approach. Like for example, right here you can see that this is an example of a database approach, and in this example you can see that I have table design, I have validation rules, I have user access and rights, I have tables. Basically, what are all of them? these are different tables, and into tables I have records, and into records and whatever it goes like fields and columns and attributes and all of these things. But in a database approach, I can say that all of these files are at one place. They are a part of one application. And now if I'm going to perform any task, like for example, if this data is going to be used by payroll application, that means that now the payroll application has the capability and accessibility to reach or to take the values or update the values from table design, validation rule, users and exercise and data. Similarly, if I talk about sales application, at the same time, if the sales application is working with data and the data needs to be amended with user and access right validation rules on table design, that means that at one place, all of your data can be accessed and it can be retrieved. This is a database approach. The data is stored in database. It is structured as a collection of records where each record is made up of field. I can give you an example of a relational database. A relational database is that in which all of them are combined together. However, the problem that I was facing in a file-based approach have been solved here, because now the storage space is not wasted because you have no redundancy. Non-redundancy, this one redundant. Redundant means duplicated data. Now, if all of your data is being amended and edited by one program, that means that your data is not being repeated. Your data is accurate, your data is efficient, because if one application is available in another application, or all of the applications are synchronized with each other, your data is consistent. Your queries are also not dependent on the structure of your data, and they are combined together to create an efficient means. So this is when it comes to a flat file database and a database system. So I hope that both of them are clear to you. Do you have any queries?
No, sir.
Now in the next part, I'm going to discuss with you regarding these records, columns, and fields, since they are a bit confusing, right? And these are all of the terminologies of a relational database. That means that if I want to define the structure of a relational database, we need to able to use we first be knowing to be know to that how can we use that. So what is a relational database? A relational database data structure can look similar to a file-based structure, as it also contains the records and fields. You know it. What is a table? A table is a group of similar data in a database with rows for each instance of an entity and columns of each attribute. A record is a raw in a table in a database. A field is a column. Again, a record is a raw and a field is a column. So let's look into it one by one, all of the examples. Like for example, right here I can see that a database of students in a school could contain the table student with a record for each student that contains their first name, second name, date of birth, and class ID. So right here, this is the table. You can see that this is a complete row and this is a record. Whereas this is a column and this is a field. Now you do rather see that the data is independent of the programs that are processing it. That means that the data is not dependent. The data is completely independent, and these terms such as records and fields are used in file processing as well. What is an entity? An entity is anything that can have the data stored in it, such as a person, place, event, or object. An entity is an individual data item stored for an entity. To use the same example, let's discuss this. Here you can see that each of your column is an attribute. Like first name, this is an attribute. Second name is an attribute. Date of birth is an attribute. Class ID is an attribute. And each row is a tuple. What is a tuple? A tuple is an instance of an entity which is represented by a row in a table. That means that all of these things are a tuple that are instance of an entity, example of an entity. You can see that each row here is a tuple because a tuple is an instance of an entity similar to an entity, and each column is an attribute. So data is shared among these applications in order to ensure that your data is consistent, your data is being updated, your data is being controlled. It is not necessary for you to manually update your data. There are different types of keys that we have to understand, and the first one is an candidate key. So what is a candidate key? A candidate key is an attribute or smallest set of attributes in a table where tuple where no tuple has the same value. Like for example, in this table, you can see that I have some symbols, I have some name, I have an atomic weight, and all of these attributes are known as your candidate keys because they can be considered, all of them are attributes, or they can be also be considered as a set of attributes in a table. Similarly, you can see that your symbol is that one unique identifier that is going to be considered as your primary key, and your name and atomic weight are going to be considered as secondary keys. What is a secondary key? A secondary key is a candidate key that is alternative to the primary key. That means that it is not an unique identifier, but it is unique in itself. So I have discussed with you that what is a candidate key? A candidate key is an alternative to the primary key. Yet it is going to fulfill the same obligations of a primary key, but it is not that one. For example, a database of chemical elements contains a table element with the attribute symbol, name, and atomic weight. These attributes are unique to each element. So that's why all are candidate keys. Like right here, you can see that most tables have one candidate key, which is used as a primary key. For example, the student table could have an extra attribute, student ID, which is unique to each student. So right here, student ID is your primary key and the candidate key. Now, if I specifically refers to a foreign key, I have discussed with you that a foreign key is a set of attributes in one table that refers to a primary key in another table. Now, look closely here. You can see that class ID, your class ID is the foreign key, and your class ID is a primary key in another table. This is a foreign key. That means that if I have a student ID, first name, second name, date of birth, class ID 7A, that means that the 7A class ID is also going to have a teacher name and a location. This is an example of a foreign key. What is a foreign key? A foreign key is a set of attributes in one table that refers to the primary key in another table. That means that it is linking the both of the tables together. Class ID is the primary key, but class ID is a foreign key because it is referring to another value in a table. So do you have any queries till now with examples?
No, sir.
All clear?
Yes.
Now, let's discuss the relationships. Now, when I'm going to discuss to you regarding the relationships are formed when all of the values in one table are connected to another table. Now, their fields, records, and columns can vary as to how many of the fields are connected to other table. But what is a basic definition of a relationship? A relationship is formed when one table in a database has a foreign key that is referring to a primary key in another table. We need to ensure referential integrity, that the database must not contain any value of a foreign key that is not matching to your primary key as well. Like, for example, this is an example of a relationship that both of them are connected to each other. Relationships, however, can take several forms. Like, for example, it could be one to one, it could be one to many, it could be many to many, and it could be many to many. The relationship between a student and class is many to one. The relationship between a student to class is many to one because in a class I can have many students, right? I have many students, and all of them are in one class. So this is a relationship of many students in a class, in a students to a one class. As one value of the attribute class ID may appears many times in a student but only once in the class. In order to speed up the searching for data, an index can be used. This data structure built from one or more columns in the database. The student table could be indexed. Like, index means that 1, 2, 3, 4, 5 into an alphabetical order as well. So relationships can also be used when you are working with sorting your algorithm as well. What is an ER diagram? Now, relationships, we are going to work on it with the help of an ER diagram. An ER diagram can be used to document the design of a database. It provides you a visual representation. This provides an easily understandable visual presentation of how database are linked together. Like, for example, here you can see that this is a student's table. This table is containing student ID, first name, second name, date of birth, and class ID, and all of them are linked to your class ID, teacher name, location. That means that there are many students in a class, but all of them are being linked to one class. This is a relationship from many to one. So relationships can be considered as mandatory or optional. However, uh, you should be knowing that how you can define each relation. So these are some of the common terms. Like, for example, if I want to make a relationship with a one database, that it has to be like this. If it has to be many, then it has to be like this. If it is one and only one, I'm going to explain you this as well along with the examples. Zero or one or many, zero or many. Entity relation diagrams show the relationship between each entity, and there are three types of entity relation diagrams as well that we have discussed. The first one is a physical one. Physical means that the structure of your data that is or will be used within a relational database, that it should meet the both the business needs and the data needs as well. So when it comes to a physical, it means that it should be meeting the certain requirements for both of them. When it is a conceptual diagram, a conceptual diagram is used along with the analysis stage of your system lifecycle. A conceptual ERD shows the relationship between your existing entities within the business and attributes. It is used in your analysis stage because you are making the concepts. When it comes to an logical, logical is an extension of the conceptual diagram that includes your data types as well. So let me summarize this. If it is a physical, that means that it is used within a relational database that meets both your needs, such as business and database. If it's conceptual, conceptual means that now you're working on the analysis stage, a conceptual one. And if it's logical, logical means that now it is also going to include your data types as well. And certainly, I have different work examples right here as well.